So there are still a few people standing in the stairway here. Can we, if you've got an empty seat next to you, can you scoot over so that everybody can sit down, please? I promise you the person next to you is not going to be a scary person who will kill you. They might smell, but it's only for an hour. And for those of you who are still standing up, just if you see a seat, go in, grab it. We've still got a few more minutes. I just thought I'd see if I can get some organization going on. Okay, people chose to sit in the stairway. So apparently the people in the audience are scary and smell and dangerous. But that's fine. I'm okay with that. I'm up here. I don't have to care. Yes, you're more than welcome to sit right there. That is fine. Let's see if you can start a trend, if I can get more people sitting in front here. So if you're still standing up over there, either just jump in and get a chair because there are a few spread out, or stairway seems full now, but you're more than welcome to sit down here with these brave people who dare be this close to me. You can go, there's a chair up there. If you go in where you're right now, there are a few spread out. Just get an empty chair, sit down, and start awkwardly chatting with the person next to you. No, don't do that, by the way. Sorry, we're all developers. We don't like to chat. Yeah, exactly. Sit down, get the Twitter handle of the person next to you, and then tweet that person. That's the way we communicate. Okay, are we... I'm going to call time. It's pretty full in here. So everybody having a good day? Everybody's full from lunch? So everybody's come in here to sit down and have a nap? That was my thought as well. Should we do it together, or should I actually annoy you with a presentation? I'm gonna go with presentation. There's a lot of interest in Docker, which is cool. So we're going to be talking about Docker today. And my name is Chris Klug. I work as a weird person at a company called 1337 in Sweden. Which means, by weird, I don't fit into the normal mold of what we normally have at our company, because we're a consultant agency with lots of really good people who go around and consult and help people, and then they have me. I spend a lot of my time going to conferences, because the company is all around sharing knowledge. So we do organize a conference in Sweden. We do send around people to conferences, both as speakers, as attendees. And I do that a big part of my time. And then sometimes I go and consult at agency with companies as well, and destroy their software and try to teach them on how not to do it, I think. But today I'm here to talk about something that I actually don't do much in my own work, which is Docker. And I really love Docker. And I've been doing this for almost 20 years now. How many has been around since I built my first website in 1996? How many of you have built websites since that age? A few hands, okay. Professionally, I started 2000. How many have been around since 2000? Okay, so I'm the old guy. I was at this talk earlier today when Joe said, if you're not old enough to remember Power Rangers, I sat in the front and went, I am too old to have seen Power Rangers. But it's interesting, the longer I go, the less I care about tech. This sounds really bad at a tech conference, I'm sorry, but I don't go home and play with my computer in the evenings. I have other stuff to do, and I do it less and less. And over the last probably 5-6 years, I've played very little with my computer on my own spare time. I do it to get paid. But Docker is one of those few technologies where I found it, I started playing with it, and I really fell in love with it to the point where I would actually spend afternoons, evenings, weekends playing with it just because I like the idea and I think it can solve a bunch of problems. And out of that came this. So, we're going to be talking about deploying software, right? How many of you in here are deploying software as part of your job? How many of you are not deploying software as part of your job? What are you guys doing? Okay. I'm just gonna assume we all know that at some point we're delivering software at least. And delivering software is interesting, or deploying software, because it's all very different. Every single project is different, and it's good to note as a background to my talk that I have a pure .NET background, so I am C# basically only, except for web front-end stuff. And I've worked as a consultant most of my time. I've also been a trainer and worked at the product company, but most of my time has been jumping from client to client, which gives me a slightly different view on how we do software development, as opposed to if you're a company that has a piece of software that you get to work on continuously. So deploying software for me has always been interesting, and we always end up in this situation where, oh, we have different environments, right? I've been in so many discussions with clients and different projects, and we almost every single time end up with at least these different environments. We have the CI/CD environment. Sorry, we don't. We start out with our dev environment. That's where we start, right? Then we take our code and we shove that to CI and CD and have that automatically built and tested and all of that, which is what everyone is doing nowadays. And then once it's gone through that, it might go to UAT, and then because we have to have user acceptance tests, so the client will go in and try stuff there, and then when they're okay with it, we take that and we shove it into something else, some form of production environment, which for me has been Azure for the last probably 8 or 10 years. And currently I'm going towards Amazon in my current project. So we end up with a different environment. And as we plan projects, I always get, oh, we got these different environments, and I go, they have to be identical. And clients go, they're pretty much identical. Yeah. Pretty much doesn't cut it. It has to be identical. You cannot have it's kind of the same. And it's not just a matter of hardware, being that they're deployed to different actual machines. As long as the machines have the same spec, it should be quite fine. But it's also all of those surrounding things. All of the software things that needs to be installed on that server, all of the services that has to run around it that you need to configure, and oh yeah, we need to get IS installed, and IS needs to be configured in this way for it to work, but on our dev machine, it's actually running slightly different, and then on, you know, in production, we actually need to have a slightly different, it all ends up with hard to deploy software. So are we the only people in the world who send oddly shaped packages to different destinations? And I know that this is going to sound really, really annoyingly stupid, but we're not. There is a long history of many, 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 many years of human beings sending shit around the world. Pardon if I'm not allowed to swear, but I just said shit. Sending stuff around the world. It started out with them riding and have the Pony Express and delivering packages like that, and then they've had them on trains, and they've had them in airplanes, and they have them all over the place, and they've figured out that they can ship stuff around the world, and it's oddly shaped packages. That's the way it works. But they've all figured out that we cannot do it like we've done it in early times. We cannot just have weird shaped packages. So instead they decided, let's make sure that everything is shipped around the world in a container. Containers are awesome. I have a weird fetish for containers. I don't know why. There's just something about containers that makes me kind of happy. I know it. In many ways. The cool thing about containers is that this little chart down here actually tells you the different versions of containers that are available. So there are a few different versions of containers available. There are a couple of different lengths and a couple of different heights. But nobody really cares about the container as such. What everybody cares about are the corners. Because in the corners, you've got little attachment points. And with the defined sizes, it means that they will always be in exactly the same place. So I can take my container and I can pack that in Sweden, and I can shove that off and ship it to China. And when it arrives in China, they can handle my package or my container because it will fit in to whatever they have built. So they can go ahead and take my container, and I can put it on a truck in Sweden, put it on a boat from Sweden to China. In China, they can pick it up with a forklift and then build a house out of it. Okay, not really, but, well, you can, and that's kind of why I've got an obsession with containers, because I want to build a house like that. But the idea is that if we can come up with a format that is sort of the same around the entire world, and we can define these integration points of how do I actually fit this thing into my system, we're good to go. And that's where Docker comes in, and that's actually why you even got the little containers on top of a whale. Docker is all about defining that container structure. It's all about setting the size and the width and the height of your container so that it fits. So that whenever I want to deploy my thing, whatever it is, I take my thing, I put it inside of a container. The container has the same shape because it's a Docker container, which is a standard, and I can take that container and I can send it off to any hoster in the world, and they will have the connection points to get it to work. So it's kind of like a VM, but it doesn't have an operating system-ish. So how many of you have ever tried packaging your software as a VM? How many of you have, keep your hands up, I want to see this, you've got strength enough to keep them up. How many of you have successfully made that work and thought it was a good idea? There's still one hand, I'm impressed. So shipping it in a VM is kind of the same idea, but there are a couple of really big problems with doing it in VMs, mainly size. So what they do in the case of containers and Docker in this case, is that they make some changes compared to a VM. So if we look at VM versus a container, virtual machine, VM. Infrastructure. There is always going to be infrastructure. Even if your boss comes and tells you, we're going to put it in the cloud. The cloud means somebody else's machine. There will be hardware at some point. It's just that in the cloud you don't care, and on your laptop you've got it in your lap. On top of that, we put an operating system. I'm going to assume Windows, considering that I'm a Microsoft developer. On top of that, we put some form of hypervisor. So in Windows world, that is Hyper-V. And on top of that hypervisor, we create our virtual machine. So the hypervisor's responsibility here is to create what looks like infrastructure, like hard drives, CPUs, RAM, network adapters, all of that physical things that you normally shove into a box. But the hypervisor generates it and makes it look like that is what it's getting, but it's really just software. So it shares the same infrastructure. But inside the virtual machine, it believes it's running on top of the infrastructure. So it adds an operating system. And then on top of the operating system, we add whatever binaries and libraries and application that we need inside that VM. And on top of that, we add our little app. Being that I'm a web developer, my apps tend to be in the size of megs. Maybe a few megs. The rest of the VM, gigs. 10, 15 gigs with my little app on top, like a crown jewel at the top. And also the operating system in there is then open to and vulnerable, so you will have to have patching going on in there, so you have to maintain that operating system and all of it on your own. Okay, cool thing, we can take more of them, and we can shove more of them on top of our physical machines, so we can get higher density, which is really, really nice, but it has issues, because each one of these VMs end up, as I said, being 10, 15, 20 gigs. And even if we have big, fast internet connections, gigs take time to download. If we go over to the container world, we've got infrastructure, that's still going to be there. We get an operating system. I'm going to assume not Windows. I'm going to assume Linux, in this case. I will come back to Windows. But we'll say Linux of some sort. Then we put a Docker engine on top of that, no hypervisor. And on top of the Docker engine, we put a container. And inside the container, we put our libraries and our binaries. And on top of that, we put our app. Which means that the whole layer of the OS, which is 10, 15 gigs potentially in the Windows scenario, disappears. What happens instead is that the container is going to look at actual hardware. It's going to go straight to hardware. It's going to go through and find an operating system. But it's siloed off completely. It's used in its own namespace. So whenever you do something inside of your container, like look at the hard drive, you're going to have a virtual hard drive. It's not virtual in the way of a hypervisor, but it's not going to be the same hard drive that you see from the host. So if you install stuff on the host, it's not going to be visible inside of your container. If you install apps on the host, they're not available inside of the container. So the container is going to get the minimum core of the operating system that you got on the host, and then it builds on top of that. So in the case of Windows, for example, you run Docker on, or containers for Windows on top of Windows Server, for example. Even if you on Windows Server go and install, say, IIS on that machine and a bunch of other of the profiles and features that you can install on a server in the Windows world, once you put your container on top of it, all is gone. It's like you were on that machine. Inside of your container, the world looks as if you were on a completely clean Windows install with nothing on it. So they're getting the same idea of a clean bill of slate for them to work on, that we get a virtual machine, but instead of having the OS inside of the VM, we use the host that is on the actual machine that we're running on, which is way more performant, and we don't have to have an OS in there. So our containers can end up being megs. In the Linux world on top of that, it actually means that we can put another Linux distro on top of it. So if we're running Ubuntu in the host, we can actually switch and go over to use Debian inside of our container, which is kind of cool. We can't do that on the Windows side at the moment. So it makes it very nice and small. And once again, we can put more of them on there. So we can get higher density on our servers, which means that instead of having all of these servers with very little running on it, we can shove in as many containers as we want until we get a nice CPU and memory resource usage on that machine, so we don't have unused capacity in our data centers. So what's inside of a container? Well, a container, actually outside of a container, so the anatomy of a container starts outside of the container, is a host and a host OS or a kernel. Let's call it Windows or Ubuntu or Debian or something like that. On top of that, my container defines a base image. In this case, my container wants to work with Ubuntu. So I'm going to have to run a Linux host, and then in my container I tell it, or rather for my image I tell it, I want to start off with Ubuntu. On top of that, when I start my container, it starts a container in a writable layer up there that is using the Ubuntu base image. A base image, or the images, are always read-only. So once you've created an image, in this case an image containing Ubuntu, it can never be changed. If you make a write inside of your container and write something to disk, you're writing to another layer on top of that Ubuntu image. So you're never destroying the original image, you're always creating new stuff on top of it. And each layer is basically like a diff disk on top of the existing disk. Has anyone ever worked with VHDs and diff disks and base disks in not a lot of hands coming up, okay. Bad idea to use that as an example. Just imagine that at this level, you've got the actual hard drive on your machine. Then you put the base image on top, and that is basically like a shim. It's like you add a layer on top of your hard drive, and as you look down and you start reading at the hard drive, it will read that layer and then anything that's underneath it. So if there's a 1 in that layer, it's going to read a 1. If it's empty, it's going to read whatever is on the machine underneath. And then you build these layers on top of each other, creating this dynamic system that you need. So in this case, I've just got Ubuntu on top of it, and then a writable layer where I can write my stuff. So we've got images which are read-only, which is basically the blueprint of what we want to have, and then containers are running instances based off of that blueprint. So for those of you who were software developers, there were a few of you not shipping code, which means that you're either not software developers or you're not shipping what you're building, which is scary. You can see your base image as your class, your definition of what you want, and your container as your instance of that class, which is the actual thing that is running. And then we can put multiple containers on top of the same image. So if I have 557,000 containers on my machine, all running off Ubuntu base image, there's still just going to be one base image, because that's read-only, so all of my containers can reuse the same image. We can also go and say, hey, by the way, actually, I want to have another image on top of Ubuntu, and I want to have one that adds .NET Core. And then on top of that image, I want to have another image that takes Ubuntu with .NET Core and adds some extra prerequisites that I need for my app to run. And then I create a container out of that. So this is the way it works. So if I'm going to show you a bunch of stuff. Among them is Microsoft's image for .NET Core. Microsoft does exactly that. They have a base image. It's not Ubuntu. They have a Debian one, I think, or an Alpine. And then on top of that, they add .NET Core. And then when I go in and use it, I know that everything is already installed. So I can just pull that image, and I know that .NET Core is already up and running because I have no clue on how to get .NET Core running on Linux. With a container image like this, I just go and say, I want that, and it has everything installed. They have a build one, which is a base image, .NET Core, and then on top of that, they have the SDK, and Gulp, and Grunt, and NPM, and Node, and all the things that you need to build your app comes prepackaged for you. So you just pull that image, and you have that image to work with, which is really sweet. And also, being that it's Linux, I can actually go and say, hey, by the way, I also want to run this thing that runs off Debian with Emacs, and I want to run my container on top of that. So with Linux, we can change the distro of Linux that we use using a microkernel, whereas if we're running Windows and Windows containers, we can only stick with that one version of Windows that we have on the host. So I've been talking about images a bit. So what does an image look like? Well, an image is basically based off a parent. Every single image in the world has a parent. How does that work? Because somewhere there has to be something that doesn't have a parent, right? Somewhere it has to start. There is an image called Scratch. Scratch is empty. And if you know what you're doing, you can use that one to get started. If you don't know what you're doing, you start way higher up than Scratch. So you point at your parent image, and then you tell it, I want to have a new image. And to build my image, can you, and I reference that, can you please copy files A, B, and C from my machine into that image? So it copies my files. Then, can you please set the environment variable called XYZ inside of this image as well? And then, oh, by the way, can you please copy files X, Y, and Z as well? And also set the entry point. So the entry point in my image is that exe that starts running when I start my container. A container only lives for as long as the root exe or the root executable is still running. So as soon as, in this case, x.exe finishes, container dies and disappears. So you need, if you want to have like a web server, you need to have something that keeps it running. You need to have a process running inside of the container for it to keep living. And each one of these things that I put into gray boxes are what is called a layer. So a layer is like basically what I was talking about, the layers, and an image is built up on several layers on top of each other that creates a fixed thing that I can use. But the cool thing is, and then I can put a container, but the interesting thing is, if I create another image that actually does exactly the same things, copies files A, B, and C and sets environment variable X, Y, and Z, Docker figures out that I already have a layer for you that does that, so I'm not going to replicate that. I'm actually going to reuse the one that's already there. It looks at set environment variables. I already have a thing that did that, so I'm going to reuse that. Oh, you're copying other files. Now I'm going to start adding another layer that is separate from the other one. So it tries to reuse layers as much as possible so you don't overflow your system with images and layers and data, and instead keep it very small. An image, if you look at Microsoft's images for ASP.NET Core, the build one, it is 2.2 gigs, or 2.02, sorry. So it's 2 gigs big. You don't want to have 2 gigs times 56 times on your machine. You want to keep as few of those as possible. So if you can reuse things, it makes it a lot easier. Okay, so now we talked about images. You know how they work. We know what containers are, basically a running instance of that image. So how do we get images? We can build them ourselves, or we can go ahead and we can pull them off somewhere, off a repository or a registry. So how do you pull that? Well, you go into your command line and you write docker pull, saying, I want you to pull an image for me. It's just like git pull, same thing. And then you give it the name of the image that you want. In this case, 0:/myimage, which is one that I don't actually have up there, but it could have been there. And if we look at that command, that is the command that you write on your console, but it actually turns into that. So it goes ahead and says, if you don't specifically tell me what image registry you want me to use, I'm going to use Docker, hub.docker.com. That's kind of the central repository for Docker images. But you can go and switch and actually write this full thing out, and then instead of hub.docker.com, you can have your own custom image registry. And for example, if you're on Azure, Azure has a pre-built system for you. You just say, give me a new image registry, and it stores stuff in blob storage for you and gives you an endpoint that works with Docker. So if we look at the address here, that address is not actually the address that's being used. That is the address that's being used. So it adds a tag at the end, and that's a way to identify which version of this image do I want. And you can add whatever you want as tags. It can be a version 1.0.0.0, or it could be my beta version, or the Windows version of this thing, or whatever. It's just a string. But the last version of your image that gets uploaded to that address will have the tag :latest. And that gets added by default by Docker if you just do Docker pull. So what we get is we get the registry, we get the repository, basically the name of my image, and the tag that I want to use. That's all we need to know to be able to get an image. You run that, it pulls it down, and it ends up on your machine. So how do we get started? How many of you feel comfortable if I tell you that you're going to have to go and install a Linux VM on your machine, and then install a bunch of prerequisites on Linux, and then run the Docker engine installation stuff on Linux? Anybody feel like that's something I want to go home and do? A few of you know more than I do. For me, that's what I thought I was going to have to do when I started doing this, and I realized you don't. What you do, and also, by the way, that's not going to work, because you're going to have to do a bunch of really magical network stuff to get that to work on Windows. So what you do instead is you go to docker.com and you go and look for Docker Desktop. Docker Desktop, you just go download for Mac or for Windows, and you install that, and you get a little systray thingy that runs Docker for you. So that thing controls a virtual machine that runs in Hyper-V. So in Windows, you need to have Hyper-V turned on. So it creates a little Linux VM on your machine with Docker installed, sets up all of the networking, which I'm going to show you is really complicated, and gives you a little command line tool to sort, or a systray tool to actually work with it. Do not work with the container through Hyper-V Manager. Always use that little tool that you get on the left-hand side, which is Docker. And also, they install the Docker client for you, which is a docker.exe and Docker compose.exe, which are small executables that you use to run the application. And it configures Docker, the client, to communicate with your virtual machine. So all you have to go and do is then go and run Docker version, and it looks as though you're getting stuff from your local machine, but what is actually happening is it's communicating with that Linux VM to get the information on that VM. There's a bunch of really cool stuff going on, and it just works. So what does it look like to run a container? I'm going to show you probably the least impressive demo that you've seen all day. But I'm still going to do it because it's kind of cool. So this is just a cmd.exe on my machine. I have Docker desktop installed. So we'll do Docker. That's what everything starts with. Run. I want to run a container based on an image. -it actually stands for -i-t, and it also has --interactive and --t something. -it is fine, and you can think of it as interactive. It basically connects any outgoing data, anything that comes out of the container, any console write lines, any standard out, goes to your console, even though it's inside of a Linux container. And anything you type goes in as standard in. So basically, I'm attaching to a new running instance of a container, and I can tell it that I want to run Ubuntu, because I happen to have the Ubuntu image on my machine. Run that. Ta-da! Okay, nobody's impressed. That is... No, I'm just kidding. You really don't have to applaud that. That is really stupid. But this is me inside of Ubuntu, running inside of a Linux VM, inside of my Windows machine. And I am root at the moment, and if I go ls and have a look at it, you can see that I'm inside of a Linux machine, and I can list all the files and everything like that. Being that I am completely useless at Linux, I don't think this even works. No, because if config is not available inside of Ubuntu. Cool. remember that. I'm going to exit out of this. As soon as I exit, bash, the exe file or the executable running inside of that container, dies. As soon as the running executable dies, Docker container dies. So if I go and say docker ps to list all of my containers on my machine, there are no running containers. If I go docker ps-a to get all, you see here that there are two containers here. They're a little bit hard to read with the formatting. This one down here you can just completely ignore. It's just me running Microsoft SQL Server inside of a Linux container because I don't want to have SQL Server installed on my machine. So I spin up a container with SQL Server whenever I need it. What you want to look at is this thing here. It says that there is a container. That's the name ID of the container. It's based on that image. It ran that command inside of that image. It was created about a minute ago. It exited 20 seconds ago when I ran the command. And it is called, it gives all of your containers a name unless you specifically give it a name. So it became sharp, yeah, not going to try that. Sharp something. So I can go ahead and delete that. I can just do docker rm. And to remove an image or a container, I have to give it the name or the container ID. Cool thing is that I only have to give it enough characters to make my ID unique. That is the only container where the ID starts with a 1. So I can just do docker rm1 and it will delete that one. If there is a duplicate or it ends up being more than 1, it will say I cannot do that, it's not a unique ID. So you're not going to screw up. So we'll do docker ps-a. We'll see it's all gone now. Sweet. Let's do docker run. Let's do interactive again. But I'm going to add --rm. --rm says when this container stops, just remove it. I don't want to have it lying around on my machine taking up space. Just once it's gone, it's gone. Just kill it for me so I don't have to do docker rm on my own. And then this time I'm actually going to run Alpine. So Alpine is another Linux distro. It's a 5 meg big Linux distro, which is quite impressive. As you can see, it's a little bit different because it doesn't say root, hashtag, and then what the name of the machine. It just says /. If I go in here, you can see that I have a Linux machine running. And if I do if config, it tells me everything that I need to know about the network stack inside of that Linux container, because Alpine has support for the command if config. In Ubuntu, it's called something else. What? ipconfig. So it's so in Ubuntu it's actually called the same thing as on Windows. I like that. Thank you. I think there's that nice caveat at the end. I'm gonna tell the guy on stage that I know more than him, and then I'm gonna say maybe. That's fine. I'm okay with that. I'm just gonna exit out of this, and if we do docker ps-a, you'll see that my container is gone. So it just, with the --rm, it gets killed off instantly. So what can I do with this? Well, so far I've managed to do absolutely zero useful stuff, which is not what I like doing. So we're going to do some useful stuff. So I'm going to go and say docker run. I'm going to make it interactive again. I'm going to name my container in this case for different reasons. I'm going to name it interactive build. I'm going to map a port. I really don't need to, so I'm actually not going to do that in this case. Sorry, I'll come back to mapping ports because I don't need it for this demo. But I'm going to tell it that I want to run off an image called Microsoft /ASP.NET Core build, like that. Is this what I want? Yes, it is. There it is. I'm now inside of a container running off Microsoft ASP.NET Core. It has all of the .NET stuff that I want to use. So I'm going to say mkdir app. So I'm going to create the directory in here. I'm going to go into that directory. We'll do, say there's nothing inside that directory. We'll do .NET new MVC. So it comes with .NET SDK installed. So I'm just creating a new .NET Core application in here, like that. Done. It also has everything, all the packages and everything in there. So that's kind of nice. I'm not going to start this. I'm going to go exit. We've got a thing going here. It's interactive build, but it's in a stopped mode. So what I'm going to do now is I'm going to say docker commit And I want to, so commit means take a container and turn it into an image for me. So I'm going to say, and then I'm going to add some commands to it. So I'm going to tell it that when this container or this image is used, start out by going into the app folder and make that the working directory for any command that I run. And then I need to tell it that the entry point, which is where is it going to start, is going to be .NET run. Then I'm going to tell it that I'm going to use interactive build. And I'm going to name it /interactive. There it is. That's how fast it is. It has now taken my container and turned it into an image. So if we look at my containers, you see that it's still here. I'm going to go ahead and kill that. So I'm going to do docker rm. I'm going to remove that container. It's gone. Then we can have a look at the images on my machine. So you can see here now that I've been playing around with this. Sorry. I'm just going to remove some images that I don't want. So I'm going to remove these, so keep it clean. There it is. So you can see that on my machine I have the zero-call interactive one, which is the one that I just created. I got Ubuntu, Redis, Nginx, Alpine, some Microsoft stuff, and then one at the end that I don't even know where it does, but I don't dare to throw it away because I don't know where it does. What we can do now is we can say docker run --rm to remove it when I'm done with it. Then I'm going to map a port. This is kind of cool. So this says take port 8080 on my local machine and attach that to port 80 inside of my container. Unless you specifically map ports on Docker, anything inside of a container can expose ports, but it's going to be on a private network inside of that Docker thing. So you can't access it. So mapping a port is nice because it means that I can access it from my local machine. And then I'll do /interactive. And this is where I should learn how to dance. I should have like an interpretive dance of how this builds. What it does now is it actually started everything up. So this is now, you can see the output that comes from inside of my container. And if we pull up trusty old Chrome, we go to localhost port 8080, boom. So this is kind of cool. Okay. Not really necessary to applaud, but it's kind of cool because this is running inside of a container, inside of a Linux VM on my machine with mapping network stuff all the way through. If I go back out here and I jump out of this thing, we do docker ps-a, you'll see that it's actually still running. Kind Banzai was the name of this container. And if I go back out here and I refresh, it's actually still going to respond for me. But if I say docker stop, actually let's just do 7a. I stop that container, which takes a little while because it needs to basically allow ASP.NET Core to cool down and die. There it is. And if I go back out here just to prove that I'm not faking it, it is now dead. And if I go back out here and I do docker rm7a, it is now... Oh, I had --rm, so it's already gone. The container is gone, never existed, and there's no way in hell that I'm ever getting anything back from it. So this is now dead, gone, has never been on my machine according to my machine. However, building images like this is kind of tedious. Because you're going to have to start up and then run all of your commands, and then you have a new version of it, and you have to go in and do it once again, and you have to have these scripts on how to do it, and oh crap, I forgot to do that one thing, and blah, blah, blah. And humans generally suck. We do not do repetitive things very well at all. We kind of suck at repetitive things, so we automate things. And the way to automate it is to write an automation version for Docker. So I have an app here. The app in itself is useless. We don't have to care about the app. What is important is that inside here, I have pretty much .NET new MVC inside of a folder called demo app. Inside of that folder, I'm adding a file called Dockerfile. If you are on Windows, I learned this the other day, and this is really cool. Have you ever tried adding a file without a file ending, a file extension, like .txt or anything at the end? Windows tells you to just go away. In nice terms. If you add Dockerfile ... it leaves it empty without anything at the end. Why? It's a caveat in Windows, which means that if you want to do this in Windows, you can just do dockerfile ... and it ends up being dockerfile without any dots. So what do I do in here? Well, inside this, I tell it what base image do I want to use. So I'm going to use Microsoft/ASP.NET Core build. That's the same that I just used. And I'm going to go ahead and say, can you please copy anything from the local directory, which is dot, to /app inside of my image? Can you set the work directory to /app? Nope. Thank you so much for that help. /app, like that. Oh yeah, after you've done that, can you please run .NET restore? So these are exactly the same steps that I did, right? This is just what I did when I did it interactively, but here I'm just defining it one step at a time. Then I can tell it that there's a port 80 on TCP that it needs to expose. It doesn't actually expose anything at all. It just lets people know that it's there, basically. And I need to tell it that there's an entry point. So when you start this container based on this image, please run .NET run. Syntax here is a little bit different. You can either do it as an array or you can add it as a string. The array is the preferred version for different reasons. Okay, this is my Docker file. This defines what's supposed to happen to create this image. And it could be way more complicated. Then, since I do have a bin and obj folder, I actually want to add a docker ignore file. And I want to make sure that anything inside bin or inside obj is left out. I don't want to have those in there. Then we open up a terminal here. We go demo app. Then we do docker build. You'll find the Docker file in the current directory, which is dot. And can you please add a tag to it, calling it demo app? If you don't add a default tag to it, it just gets a none name, so it just becomes an ID. As you can see, it runs through every one of the steps that I just defined. So currently it's restoring packages, and it also figures out to create different layers based on your commands and a bunch of things. There's a bunch of optimizations that can be done in here, but for simple things, this works. It runs my commands for me. At the end here, it tells me something about read access on Windows versus non-Windows and everything like that. Let's just use that, and you don't have to look at it. We can now go back out here. We'll do docker images. And there it is, the demo app. So if I do docker run, let's do D. -D means detached, which means run it in the background. I don't want to have input output from it. Just run it off somewhere in the background. And then map port 8080 to port 80 inside of my container. Remove it when I'm done, and I want to base my container off the demo app image. And it's up and running. It's not, which is why I'm procrastinating to go over to Chrome, because it takes a little while. It makes a better demo when it works on the first try and it doesn't fail. It takes a little while for it to actually spin up ASP.NET Core. But now, it runs my app. And it's running, if we zoom a little bit, you can see that it's running on Unix, it's running in production mode. So inside of my container, it sets the correct environment variables and all of that, and it gives it a machine name and so on. And this is kind of cool because with this Docker file, let's just do docker stop demo app. Actually, I didn't name it. Docker ps-a, docker rm, no, docker stop affectionate Hypatia. Okay, so the cool thing with the Docker file is you can check that in. So that can be in source control. So if you make changes to it, you put it into source control, unlock, and we can just rebuild things. So on the CI server, we just pull the Docker file, we build, and we shove that off to the registry, and we're good to go. So Docker images are kind of cool, and we can base them off interactively building them or running a Docker file, which is what we normally do. So what about storage? It's kind of, you always come back to we need to store stuff. And in the case of Docker containers, we should think basically cloud. In cloud, you can just assume that your container is going to be killed off and reset up somewhere else over and over and over again, and you never know what host it's going to be on, and it's going to move around.
which means that storing things is something you want to do external. So preferably you want to put your stuff that you want to store in a database. So you have a database service on the side. Or you have some storage area, S3 buckets or Azure blob storage or something like that on the side, because then you don't have to care if your container moves around because storage is external. But if you do want to start using storage inside of your container, there are a couple of options. You can use the container itself. You can do what's called a bind mount. You can do volumes, and you can do temp FS mounts. So containers is literally what it sounds like. You do, in the .NET world, file.write, and you write to file, and that gets stored inside of the writable layer inside of your container, and whenever your container is killed, your data is gone. Not a great solution for anything persistent, a very great solution for temporary files. Bind mounts are interesting because they bind an address or a path inside of your container to a physical folder on the host. So I can expose a host on a folder on my host, my machine, inside of a container at a path. So I showed you that I happen to have Microsoft SQL Server running inside of a container on my machine. To give it persistent storage, I have a folder on my actual Windows machine with all of the MDF and LDF files to run SQL Server, and then I map that path or that directory into a path inside of the container. So whenever SQL Server starts up, it looks into that folder and sees here are all the files that I need. So even if my container dies, which kind of happens once in a while when you do update your Docker desktop, I can just recreate a new container and it's up and running. Volumes is a way of letting Docker handle storage for you. And you tell Docker how to create volumes. You can either go and say, here's the volume and it gets stored somewhere, but it's still local to one host. Or you can go and say, I want to set up a volume called my files, but it's going to be backed by an S3 bucket in Amazon, or an Azure blob, or some other storage, or you have a storage area network on your on-prem machine. Then you can say, here is a volume that I can write to, and that is being backed by that big stack of servers over there, so if a container goes up and down, it doesn't matter, but it still looks inside of the container as it's writing to a local place. And for temp FS mounts, those are temporary file systems, temporary paths in your container, that whatever you write in there is just temporary. It never gets written to disk. All the other stuff will actually get written to disk at some point. Temp FS mounts are RAM only for things like security or access tokens and credentials. So if you put something in a temp FS mount, it never gets written to disk, which means that even if somebody gets access to a host and an old hard drive, they will never be able to get your credentials out of that. So let's look at setting up a bind mount, because those are kind of useful. So to do that, I have created a little app. It is dumb, but it works, which isn't all of my apps. I have something called Image Viewer Web. And Image Viewer Web is basically a very simple website where I can look at images, and what it does, it looks for image files inside of www.root/images, and any file in here that is an image file gets rendered on the web page, and I can upload files to it as well. Actual code implementation makes no difference. We don't care. I have a Docker file in here. The Docker file in here looks pretty much identical to the one that I just had, because it's kind of the same thing it's doing. And by kind of, I mean more or less exactly. So with that in place, I can go and say, Docker build, please build the current directory, and name it image viewer. It builds my app for me. 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 And once it's done, I've got a new image. So we can do Docker run. Actually, let's do this first so you can see. Docker run, and I'm going to run. So what I want to do is I want to map a port. Once again, port 8080 to 80. You can choose whatever port number you want. It's just 8080 seems to be my default. Run it in the detached mode and remove it when I'm done with it. Give it a name and call it image viewer. And base it off the image viewer image. Ta-da! I have a container up and running. I go back out here. I press refresh. It fails. I press refresh, and it works. It takes a little while for it to spin up, as I said. And these are the two images I have in there. They're awesome. Me in a furry waistcoat. And if I go in here and I upload, and I happen to have the best picture on the internet. I found that Googling the best picture on the internet. So it is verified data. I submit that. I upload a cat riding a unicorn in front of a rainbow, breathing fire. You cannot beat that. Maybe sharks with lasers, but that is pretty damn good. Problem now is that if I go back out here and we do docker ps-a, you'll see that I have my container running. Here it is, image viewer. Let's do docker stop image viewer. Once I stop it, it gets killed, right? So it's gone. So if I do docker ps-a, you'll see that it's actually gone off the rails. It's never around. And then I run exactly the same command again, creating a new container with the exact same command. And I go back out here, and I press F5. And the best picture on the internet is gone. Can you imagine the disappointment when that happens? You don't want to have that. So how do we solve that? Well, let's do this. Let's just stop image viewer. So I'm going to run a much more complicated command, and I'm going to do it. Actually, I'll do it in here. Let's just do it in here. I'm going to take this here, which is the same command that I had before, but I'm going to add a twist to it. I'm going to say somewhere in here, let's do it there, -v for volume. Please add a volume to this container. And I'm going to add a volume based on some PowerShell stuff. So I'm going to do that, and then do env : user profile. So basically the address to my user profile /image, no, pictures. So that's basically my pictures folder on my machine. And I want to map that to /app, which is where my app is located in the container, /www /images. Run that. It's up and running again. F5. Fails, 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 fails. There it is. Ta-da! This is cool. Because, why is this cool, Chris? Let me tell you. This is now overriding. So due to the fact that I was mapping a volume of my local machine into an address that was or a path that was already used inside of the container, I overwrote the one in the container. So instead of it reading whatever I copied into my images folder inside of the image, I am now reading the files that I obviously have there. And if I go ahead and I go and upload the best image on the internet, it gets added, but it also gets added here, which means that if I kill my container and restart my container, it's still going to map towards the same physical place on my local machine, which means that it's going to have persistent storage. That is pretty awesome. So let's do docker stop that thing. Okay, so now we've seen some storage stuff as well, which is kind of cool. Keep in mind, though, that you really don't want to do bind mounts more than during development, because you're tying your container to a specific host. So if you're in a cluster of machines, you're tying yourself to a specific node in that cluster, which is why the whole idea of volumes, shoving it off somewhere else, is where you want to go. Networking. I'm not going to mention a lot about networking, except that networking is hard. And what do I mean by networking is hard? We've got the internet. On the internet, no, actually we don't. We've got my very local internet, which is my local, it should be 192, actually it's right there. No, 192.168 was what it's supposed to say. That's my local machine. Let's just ignore if it's the internet or whatever network you're on. That's my machine. It gets that IP address. Inside of my machine, I have a virtual switch from Hyper-V. It has 10.0.75.1. Inside of that Hyper-V switch, I have a Docker VM, Mobile Linux VM. It is attached to the Hyper-V switch, which gives it 10.0.75.2. Inside of that VM, I have a network for Docker, which has 172.1.7.0.1. Inside of that network, I have a container or two. And whenever a container goes down and it's put up again, they switch IP addresses. So they have a running thing. You can never, ever address a container based on the IP address. I asked a guy at Microsoft who was building containers for Windows about doing static IP addresses in there because it would make something simpler. His answer to me was, no, we're probably not doing that. And I said, why? And he said, networking is hard. So I have proof that networking is hard, and I'm not a network person. So I'm not going to do a whole lot in here, but I do want to, before I go to next, I just want you to think about the layers involved here, and that I, on this host, do you see my arrow? You do? Just took a folder on that host and shared it through 2 layers of networking and had the files available inside of my container after 2 layers of basically getting networking to work. That is why I'm saying that installing Docker for desktop sorts that out. If you install it manually on a Linux machine, good luck. It doesn't get as complicated on a Linux machine because you don't have the host and the Hyper-V and all of that, so it actually becomes a lot easier. But in Windows, it's like this. Then we have Docker Compose. Docker Compose is the idea that we have more than one container. So we often run microservices. So we run many small containers doing individual things. So with Docker Compose, we can define the different containers we want to run, or services, as it's called in Docker Compose, in a file like this. And then we can just run Docker Compose up, and it will actually create everything for me. So I'm going to quickly show you that in a demo here. Actually, I want to go over here. So I have a little reverse proxy thing here. I'm going to explain it as I write my Docker Compose file. Can you please log in? Here's my face. There it is. I cheat. I have some notes on this. So docker-compose.yml, because everything is YAML nowadays, apparently. JSON is not popular anymore. In here, we're doing version 3. Why 3? Because the documentation said so. Services. First of all, I have a web service. I have a web that's going to run inside my Docker system. And I'm going to tell it that to run that, it needs to be built, and you'll find the context inside of /app.app. So basically, where is the Docker file located? It's going to be there in relation to this YAML file. And also environment. I want to set an environment variable inside of my container. It's going to be Redis equals Redis. So that's my first container. I need that to run. Then I'm going to put up a reverse proxy server in front of it. So I'm going to use Nginx as my reverse proxy. That needs to be built as well. And the information about that is in ./Nginx. And I want to map some ports. Remember, I did not map any... Can't talk and type at the same time. I did not map any ports to my web app. I'm mapping ports to my Nginx, and then Nginx is going to basically internally reverse proxy to my web application. And inside of Nginx, I don't actually need to do anymore, but I also need to have a Redis in here, because everybody needs a cache. So I'm going to put up a Redis cache. Luckily, that's just, here is an image, and it's called Redis. Run that image for me. Save that. Go to the correct folder. Reverse proxy compose. Docker-compose, another tool you get with Docker for desktop. Up. While that runs, it basically goes in and creates my different images for me on the fly. It also creates a network for this specific set of services and attaches each one of these containers to that network. So it's an isolated network for only these 3 services. It adds static mapping inside of these containers so that if I, inside of my web application, go and try to reach something called just Redis, this here, it actually maps that to the correct IP address for me inside of that network. So it sets up a network connecting all of these with DNS resolution and everything predefined for me. So what I'm going to end up with is a 3-service system here with me attaching to, making a call to Nginx. Nginx takes my call, proxies it on to the web app on port 80. The web app talks to the Redis cache by figuring out that the Redis cache is called Redis by looking at an environment variable. As you can see, it's coming up down here that it's being attached and everything. And if I go back out here and refresh, the amount of oohs and ahs is going to be very little, but that is serving it for me. And if I refresh, you will see that the initial request state stays the same because it's actually talking to a Redis cache internally. So it's a three service setup with 3 containers and a setup network for you to work with. And all you need to do is check this into source control, and your dev team can just run Docker Compose up and have the entire stack for them. Let's do Docker Compose down. That removes my images. So that's kind of cool. I've got 3 more minutes. That's kind of cute, but it's only 1 machine. The whole idea about Docker is that we want to run at cloud scale and more machines than a cluster. And to do that, you go and you do not use Swarm, which is on the left-hand side, because nobody cares about Swarm anymore. Swarm will make sure that it deploys to different nodes, but then it just goes hands-off. So if one node fails or one instance container fails, it just goes, eh. Whereas Mesos and DCOS and Kubernetes will actually have a reconciliation loop. So you can tell Kubernetes, for example, please run this container, I need 3 of them. If one dies, it goes and sets up another one. If I add an extra one and it sees 4, it's actually going to kill one of them. So it has a desired state configuration, and it will move them around the cluster of nodes. Docker for Windows, you can run Docker on Windows or Windows containers. It's supported by Docker for Desktop as well. Problem is, images do become very big, but you can get the same features if you're stuck on Windows as well. So you can take your ASP.NET application or regular .NET Framework application and shove them into a container for Windows as well. I'm going fast here because I want to show you this, because I had to put size matters at the end. And to do that, I want to show you a little thing. I have 1 more minute or 2, and then it's TB, so it doesn't matter, he can be late. Minus 8 minutes? I don't have an hour? Oh, sorry, people. I thought I had an hour. Okay, give me 1 second, just. I just want to show you this, because this is awesome. Just imagine that I took this, but I called this build. And I wanted to make a little change here. I don't want to do .NET Restore, I want to do a .NET Publish. And I want to output it to /publish. And I want to do it as a configuration of release, like that. And I don't want to have an entry point. Instead, I'm going to do another from here. And I'm not going to do the build one, so I'm going to do the one without SDK. Then I'm going to do a copy. Somebody's going to kill me for going over. Sorry about that. -- from equals build. And I want to do /publish to /app. So basically copy anything from internal there, and then set the work directory to app, and run .NET demo app.dll instead. cd ... cd demo app, docker build ./t test run. Please go fast, go fast, go fast. Sorry. You're more than welcome to leave. Oh, it's a cool demo, though. Come on. So if everybody tweets now, and you add @1337 where I work, and say that I need a better machine. Okay, it's not happening. So what I just want to show you is that you can actually build and then copy things across containers, so you can end up with my demo not running at 2 gigs, but at 340 megs instead with ASP.NET Core. But considering that this is working fantastically, thank you for listening. Yeah, I was killed. So yeah, thank you for listening. If you have any questions, I'll be around. I am sorry that I stole 10 minutes more of your day than you really want to give me.